Hello YouTubers, and this video is going to show you how to assemble the Slot 5 fruit machine simulator. So hopefully you've downloaded the disk, let's give this a go. So if you've downloaded the disk and installed it on your USB drive, or managed to convert it to a disk on a real Amstrad CPC, or you're using an emulator, you should see the following files on screen. And I tend to use Adam, Assembler, Disassembler and Monitor, but it was known as DAMS in Europe, as it's a fairly good assembler, debugger, as it says. So there's a few tricks that we have to do in order to get this to work, because the size of the source files, etc. So first off, we're going to run Adam, and we're going to hold down space as soon as we've hit enter. If you've done that correctly, you'll see the load address in decimal, and we're just going to put in the value 1000. So we're going to load Adam in a very low area of memory. And then you're presented with the Adam interface. Press Ctrl B will switch you into hex mode. Now, at the moment, the high mem is set to quite a high value, 6F2D. That doesn't give us enough space to assemble the program. We also need to make a little hack to Adam so that we can assemble some source into higher memory also. So I'm going to press B to return back to basic. And because we load it in at 1000, I'm going to clear the screen for clarity. I'm going to poke 1081 with 255. All this does is set the value where I can assemble beyond basics storage. So you could potentially overwrite the firmware vectors. I wouldn't recommend doing that, but anyway, for the purpose of this, poke 1081 255. The offset is always 81 bytes after where you've loaded Adam. So we're going to jump back into Adam. We loaded this at address 1000. So we're going to call 1000. Now we're going to change high mem to 4FFF. So you should see something like this. Now the useful thing with Adam is that you can concatenate files as you're assembling them. So we're going to start off with main.adm. So if I list this on the screen, you can see here, fruit machine simulator, and there's a bunch of code. And then towards the end of this, we see a command, *F, comma, and then the file name. That's the next file in the chain. We're not going to modify any of this, but I just thought I'd show you for clarity. So I'm going to press N for new, so we've cleared memory completely. To assemble the program, F2, comma, main.adm. Now you'll see some screen corruption because the symbol tables are loaded into screen memory in order to do this. So I'll just hit return here. The object code address. If you remember, we set high mem at 4FFF in hex. So we are going to set the object address to 5000. This doesn't mean that the game will run at hex address 5000. It just means that the code will be assembled there, but all the correct references for the origin, the org address, will remain intact. So I'll just hit enter here, and it will now start loading each of the files, which hopefully you've seen on GitHub. Now this will take several minutes, I think, so we will return, well, we will speed this up, I think, until we get to the final object. Okay, and here the code is compiled. We then store the object data back to disk. So the command is p2 puts object code, and I'm going to call this slot5.gam for game. We could call it .bin, but we're going to use that later. So p2, comma, slot5.gam, and that will write the file to disk. And we can see here the last file that was loaded into memory, which would be variables. Okay, so we're going to hit N for new, and then we're going to get the loader for this. So G0, loader.adm, and we can see here that the origin address is at hex BE80. Remember the poke we did earlier at 1081,255? That little hack allows us to assemble code in higher memory, and BE80 is the most common area for loaders on the Amstrad CPC. The loader is fairly straightforward. We can see here that I've disabled interrupts, reset the stack pointer. If you've got a 6128, I've reset the memory bank so that it's the standard 64K, the first 4 blocks of 16K. We then call 2 load routines to load the actual files into memory, and we've got a destination address of 40 in hex and C000, which is the screen. That's where the game code is going to go, and because I overwrite the firmware on the Amstrad. And then we're going to load the loader to execute and shift the code around. So we could change the stack pointer to 40 in hex. That's quite low. The exec code, which follows, destination into 0, and the length for the execution length is set at compile time here. The execution code will load the game code from screen into the origin address, which was 814A, and we're going to set BC equal to the length of the overall code which we stored in the load program. Load that back into memory and return, and the basically RST0 will execute that code. Here's just a fairly standard loader program. So I'm just pushing the destination address where we'd like to load the code. So we're going to ignore what is in the file headers. The length of the file name, I've set this to a strict length, including spaces. We restore D, which we pushed earlier, into HL, which is the destination we're going to place the code. We're also setting the length, so I know that the last file load is the game code, so I'm not too fussed about that. And then we're going to call the final parts to load and close the file down, and it is as simple as that. So we need a slot5.spr and a slot5.gam. Slot5.gam we created earlier. Slot5.spr is provided on the disk. That's the sprite information. I do need to source the original disks with the sprites so that anybody can tidy up my rather crap graphics, let's say. And that's all there is to it. So we're going to assemble this code, and then P2 save the object, and we're going to call this slot5.bin, like so. Hopefully it comes back. B to go back to basic. I'll just clear the screen, cap the disk, and you should see there a slot5.bin, a slot5.gam, and a slot5.spr. Now to run the game, just run slot5 like so. There'll be a pause. The game code will be loaded into screen, so it'll look like some corruption. Here we go. And there we go. You've just assembled the game code, so you're free to modify the assembly, fix any bugs, make improvements, fix my rather poor grammar and crap messages, I guess. So yes, good luck and thanks for listening. Mystery. Cashbot. Fantastic.